Welcome to the Data Playbook podcast. In this podcast, we aim to build a playbook for data leaders to be successful with data. We do that through a series of interviews with other data leaders, experts, and practitioners. And today I have with me Niels.
Hi.
Niels, welcome to the podcast.
Thank you.
Can you maybe introduce yourself to the audience?
Yeah, sure. So I'm Niels. I'm a data engineer at Dataminded for almost 2.5 years. And before that, I was also consulting, but more on the functional side. So more in innovation management and implementation. But I like data engineering more, so now I'm here. And yeah, I'm coming here to talk about a client use case we had.
Exactly. Specifically, the topic of this podcast is about how to migrate to the cloud. I think as part of every playbook, if you haven't migrated to the cloud already, probably migration to the cloud is a topic that's coming up sooner or later for a data leader, right? So maybe before we dive into the actual migration, can you talk a bit about the kind of client we were working for?
Yeah, so we were working for a government client, and they actually tried to migrate to the cloud before, but had to stop due to legal reasons. And then they hired us to build their on-prem data platform. But then eventually they still decided to go back to the cloud. Well, yeah, go back to the cloud. That's what this talk is a bit about, how we manage that migration and what concepts, design choices we made earlier helped us doing that.
Yeah. So it's funny because indeed they hired us to basically move away from the cloud, right? And the end result is that we moved them back to the cloud. Can you talk us a bit through that? Like, why did they want to migrate to the cloud?
Yeah. So maybe to start at the beginning, back in 2017, they were migrating to the cloud. They started migrating to the cloud the first time. And after a couple of years, an oversight committee said like, hey guys, you need to stop doing what you're doing. You can't migrate to the cloud because there is this Schrems II lawsuit that has been won, which dictate that our sensitive data, our crown jewels, are not safe in the hands of cloud providers. Yeah. And the reason is that the American government has the possibility to demand access to data from American companies. And since the cloud providers do not keep European data necessarily within Europe, the American government can access sensitive private information, which is in violation with the EU GDPR law. And there was a Privacy Shield Act, I believe it's called, between the EU and US, which extends the GDPR also to the US. But the lawsuit, the conclusion of the lawsuit was actually that Privacy Shield was invalid. Exactly. So not upholding GDPR compliance.
Yeah. So that was a reason for them to move away from the cloud?
Yeah.
But then why did they want to move back to the cloud after all?
Yeah, indeed. So as a consequence of that lawsuit, they went back to on-prem. So they found an infrastructure partner and bought a lot of hardware themselves. I think it was $500,000 or $1 million pure in hardware alone. So they invested quite heavily, and they contacted us to be then the designers and builders of the data platform on the on-prem infrastructure. Yeah. But the relationship with the infrastructure provider was rocky from the start. Like even in the beginning, when setting up the data platform as a whole, there were a lot of outages. Everything an update need to be happened, then the platform would go down. There was a lot of uncertainty around that. And then I think that was around 23, the beginning of 23. And in the meantime, the government also started a very important project, which only ran for 2 months in a year, but was very high profile, also very sensitive data. And they needed guarantees on the uptime on the platform. And then they decided with that infrastructure provider, we can't count on them. Should we go to the cloud? Because there we have quite good uptime guarantees in terms of infrastructure. We can just copy over our data platform setting. And so they went back to the oversight committee and I was like, hey, please let us move our data platform to the cloud for that use case at least. Not for the rest, just that use case. And they said yes because in the meantime, AWS came out with Nitro enclaves, which is like a secure compute environment. So it keeps your compute separate from others.
Mhm.
And then the second part was that we had to install an external key store, which then encrypted and decrypted our data before it went to the cloud.
Yeah.
So that made the entire thing secure enough for the oversight committee to do it.
Can you dive into a bit into? You said we were struggling with the infrastructure partner. They were struggling with keeping the platform up and running. What was so difficult about that?
Yeah, difficult to say. Like, well, two parts. First, they had a contract which defined certain performance targets, like networking and that sort of stuff. And they were never able to achieve the agreed upon performance targets. I think they only managed half of that. So there was a lot of back and forth, like, hey, you need to meet this KPI. And they never could. And every time they tried to improve something, they broke the platform. So it wasn't very confident building that when they had to do updates, the platform would go down. Yeah, that's not nice. It improved a bit, but at the end, we just said do no updates for like a year. So we at least have a stable platform for the short term. And in the meantime, they started discussing like, hey, this is not manageable in the long term. We have a use case on the cloud. Maybe let's start thinking about moving everything to the cloud.
Yeah, I think because I was also partly involved in that project. I think what you said, the first part, not meeting performance requirements, was annoying, but the second part was really killing the deal, right?
Yeah,
At least in
indeed.
my experience, that you could not rely on them to roll out an update ever, because you would come back in the next morning and the platform would be down. And that's something that we're kind of spoiled in the cloud now, that it is possible to build high available systems in the cloud if you know what you're doing. And then the fact that we had no control over the actual infrastructure, the actual physical hardware, we depended on another infrastructure partner, made the collaboration very difficult.
Yeah,
right?
indeed.
Yeah.
And also a big thing about building data platforms is, in my opinion, one of the foundational things is not a technical one, but it's trust with your stakeholders. And yeah, as you put it, it's dead by 1,000 cuts. Every time the platform would go down, we had to explain to the end users like, but this and this is the reason. And to be fair, the government handled that really well. Like, they were very transparent about the issues with the infrastructure provider. So we didn't get any blame, and the platform did, as a tool, didn't get any blame. So the problem was clear, but how to move away from the problem, took some time for them. But they managed that quite well, I think.
Okay. And then, so at some point it was okay again to move to the cloud. You mentioned two reasons. The AWS Nitro environment, is that confidential compute or is that something else?
I believe it's like a separate EC2 instance that has separate compute, like fully separated from everybody else.
Exactly. And then the other reason was that we didn't store our encryption keys in the cloud anymore, right? We stored them at a third-party provider.
Yeah.
Okay. Was that difficult to make that switch?
To AWS, or
I mean implementing those extra security requirements, because it's not something we always do for every client, right? So I wonder what kind of extra complexity it brought to the project.
Yeah, I wasn't directly involved in setting the AWS environment up, but the main struggle we had was with the external key store, because there you had, that's kind of technical, but you had some latency, of course. And if I think it integrates with AWS KMS, and if it goes above 250 milliseconds, KMS times out. And we didn't have any control on that, so that caused for some issues there to get that performance up and good enough. That took quite a while to get up and running.
Okay.
Yeah.
And what would you say have you learned about this trajectory?
Yeah, I think first of all, you see like how, as I just said, like trust is everything. Like how much like small mistakes or small inconsistencies can deteriorate your trust relationship for your platform product. But also, I think kudos to the government. They manage it quite well. Like, don't be afraid to come back to earlier decisions, like challenge the oversight committee decision and to even though they already tried going to the cloud and invested this much into on-prem, to still make the decision like going back to the cloud. Like I think it's quite brave for them to do it. So I think those are two important insights for me.
You go against the stream, basically.
Yeah, indeed.
You go against.
It's not easy because you have the sunk cost fallacy type of thing, and they did it pretty well.
With building that platform, there were also new technologies that we introduced. But maybe start with the goal of the platform. What was the purpose? Why did we build a data platform in the first place?
Yeah, so the main goal of the data platform was to enable their data engineers as much as possible via providing self-service tooling. So we can multiply their efforts, and because they're with like 40, 50 data engineers, and we want them to be able to create as much use cases as possible, but in a standardized way, so they're interoperable and accessible and discoverable by different means, so they can collaborate and share data with each other.
And if you zoom into that, how did they do that before we offered that platform? Because there was a data warehouse, right? So
yeah, they had this typical monolith of a data warehouse, and at the end, things took, I think, even months. You maybe know that better than me. Took months to add a report or to add a data set to it, maybe even years. So it was very slow to add new concept there because they spend a lot of time modeling and making sure that every thing was modeled correctly. While with the new data platform, we approach it a bit more in the data product way, where every data product has its own freedom to model their data how they want, and enterprise data warehouse fits in that, but you have a bit more freedom to fit to your purpose and to your use case.
Yeah, indeed, it's true. They had I would say, an all or nothing approach. So if you wanted data in the data warehouse, it had to go through all the modeling steps, and they used Kimball methodology, dimensional modeling, and as the data warehouse grows, you add more and more fact and dimension tables, and it's more and more complex to add new stuff. But that was the only part, right? So what we saw as a result, that either you wait 6 months to a year to get your data in the data warehouse, or you access a copy of the operational system, basically, and you build your own reporting in Excel or in very ad hoc. Those were the two extremes, and there's a place for everything in the data landscape, but if you only offer those two extremes, that caused a lot of frustrations, right? So we wanted to avoid making that mistakes, and so you introduced some concepts and technologies to achieve that new solution. Can you talk a bit about the concepts and technologies you introduced?
Yeah, I think the main two concepts we introduced were like data product thinking, I mentioned before, and the other one is like how we manage access in this setting of data products, which is, we call it purpose-based access. And I think those are the two most important things we introduced. And to support that, I think in terms of technology, the important thing was what we chose as compute was Starburst. And that really helped us managing their legacy systems because at the government client, they had like every database possible, like Oracle, MySQL, Postgres, S3 storage. You call it, they had it.
Mainframe.
Yeah, mainframe. Sadly, mainframe. And what Starburst is like an enterprise version of Trino. And Trino has like these connectors which allow you to query directly different types of database via that specific connector. And then also create queries across databases, which makes it easy for us to build a platform of that to be able to share and consolidate data across systems.
And I guess what's also nice is that Starburst is a technology that can run on-prem, can run on AWS, can run in hybrid environments. So we didn't have to rebuild the entire platform once we decided to move to, like, we could keep the technologies, right?
Yeah, the platform side of things was very simple. It was actually just a copy-paste of our settings of what we had on-prem. We moved that to the cloud. I don't think we had to... I saw the YAMLs, they were exactly the same. Just called Prod 2.
But before we dive into the actual migrations, you mentioned two big words there. You mentioned data products and you mentioned purpose-based access control. So I want to dive into those concepts a bit. What is a data product according to you?
Yeah, data products is more of a paradigm. Like, how do we think about data? Like, classically, every use case was considered a project with a static beginning and even end date. And then when the end date was reached or the project was delivered, everybody rolled off and went their own ways. And then it just existed. And you hope that it kept on existing and kept on creating value, just driven by hope. And with data products, we go for with data products. It's in the name. It refers to, we think about data as more of a product, so it has a life cycle, but also it serves a certain purpose. It has a clear purpose, and it also has a clear group of people responsible for it. So it has a clear owner who manages it, but also has a clear set of engineers who are expert on that domain. And can be contacted for more technical questions or issues when some things depend on it or break eventually. Because you need to maintain, like a product, you need to maintain it. So there's always effort when things change in like an upstream source system and the things need to be adapted. And the purpose concept is also really useful because that makes it a bit makes it more discoverable. Because it's clear what the data is meant for, what the data is doing. You have this set of tables, and it serves a certain purpose. You already have a direction of like, I need something about HR, like, and this purpose is related to HR. Maybe I find the data here, and you can go deeper with data catalogs. But at least justifying the purpose as a bare minimum already gives direction on where I need to find my data, and in what form, maybe.
Okay, so if you take that one step further, you said purpose-based access control. Every data set has a purpose, or every data product has a purpose, I would say. And then how does that relate to access control?
Yes, so purpose-based access control is indeed then how we manage access to that data product. Because the purpose in purpose-based access control just refers to the purpose that the data product is serving. And so we don't give access to people anymore. We give access to data products and we add people to a data product. So the set of users, contributors to that data product, each data product has its own sources or input data products, and that data product then gets access to those, read access to those things. And by inheritance, the people put on that specific data product get access via that. And that's basically purpose-based access. And that's an extension of kind of role-based access. It depends on your setting, but it extends role-based access because your people have a certain role in your data product, like a contributor, or and that determined via that role on the data product, they get access to the other data product.
So in a way, you inherit the same access as the data product itself. So, but what is the value it brings on top of just giving people direct access to data?
You can scope it because what we avoid, or the pitfall, not really a pitfall, but if you don't do role-based access, eventually you just have your union of rights across all data products. I'm a developer, and now I see all the tables across all data products I'm a developer on. Especially centralized teams can see all the data, and you necessarily, especially with sensitive data, you don't always want that. And with purpose-based, you can really scope it like, I'm now working on purpose A. I see the input of purpose A and also the resulting tables of purpose A, and I just work in that scope. And when I want to work on purpose B, I can just move my scope to purpose B, and the things I can see moves along with me.
Yeah. So in a way, using purpose-based access control gives you a much more limited set of data that you need only to deliver that specific purpose, right? So you might work on one purpose. Let's say I'm going to do operational improvements on for a department or whatever, and there I can see sensitive customer data. But then when I want to do marketing campaigns, I'm not allowed to see that sensitive customer data anymore.
Yeah.
And in a way, it fits better with how organizations reason about data, right? They want to have some kind of catalog of what are you doing with the data, who is using it for which purpose, and if you implement it into the systems, it's enforced, right? It's you don't need to deduce it or like reverse engineer, like who has access to what. You you know that because you implemented this governance from the start, you know that what you see as list of purposes and accesses that they have, it's also enforced on the system, so you don't have to worry about. Okay.
Yeah, and I would add to that, an added benefit is that you don't have the complexity of like, I need this engineer to help me contribute on purpose A. You just add them to the purpose and everything is handled. It's a kind of an abstraction layer, like everything is handled before it. You don't need to find out, like, I wish fake group is associated with this kind of purpose. Like, you provide some self-service around it, which makes it easy to manage this.
Yeah,
and this allows us, the owners to manage it, the business to manage it themselves. You don't need any input from the platform team. The owners themselves also can manage their access. And that's also a quite strong point.
Exactly. You mentioned a very good thing there, because if you like traditional role-based access, it's true what you say. In central teams, either very often defaults to, as an engineer of the central data team, you get access to everything because, you will touch every use case at some point, and the union of all those accesses is the entire. So let's not bother. Or you go through, let's say, a very complex hell of shopping data access, which you think you give control to the business, but you don't, right? Because then the business sees Chris wants access to this CRM database. Who's Chris? What does he need access for, right? Should I click yes or no? I don't know, right? So for the business, that doesn't make any sense, that request. Where it does make sense is like the CRM database is useful in a project around marketing upsell. Do we want to allow that, yes or no? That's a reasonable question to ask, right? And then the business can also, because that was also important, they can also revoke their permission, right? If at some point they say, look, we're not comfortable anymore that data is being used, they always have a kill switch to say, stop, you cannot use that data for that purpose anymore, and automatically the access is revoked, right? Okay. So that helps a bit understand the data product concept and the purpose-based access control. How did you apply this at the government?
Yeah, so in terms of data governance, like managing access and following up on data products, we built a lightweight Streamlit application, so a Python application to exactly this. This contained all the data products that we had on the data platform, and then also had a clear assignment of we need a description, we need a purpose, we need a clear owner, you need to define your contributors. You could do that via that application, and this allowed the owners themselves, actually everybody, could request access to data products, could add contributors to data products or create new data products, but the owners had to give approval on those actions. And that allowed, we as a platform team didn't need to interfere at all in that process. They could just manage that on their own and keep in control there. And the second part is more on a technical level. As a consequence to, for example, creating a data product, we provisioned as a platform certain things. So we knew we had a purpose, but to that purpose, you need some technical stuff to be able to bring value according to that purpose. And at the government, since most engineers were comfortable with SQL, we decided to introduce DBT. DBT is known for its modularity and allowing software engineering best practices into the data engineering world, which is very popular the last couple of years. So they got one DBT project according to a specific template, setting up authentication already, so they didn't need to worry about that. Also, like best practices on how to structure your project were already there, so you just had to focus on the SQL logic, actually. And then
so in a way, it's a paved road. You provide it to all the data engineers. So this is the way we do things here. We set the security correctly, but also we give you a set of best practices so you can focus on the actual business logic and not on all the boilerplate code, if you will.
Yeah, indeed. And to add to that, like this paved road is fine, but you also need them to teach them a bit like how to drive on the paved road, maybe, so to say. So we also invested heavily in organizing trainings as well as for the owners to how to manage a data product, how to think about these things, and to the data engineers themselves more on a technical level, like how do you build a good DBT project, like how do you do data testing, how do you do unit testing, so you make sure that the data quality is there and then that each data product has a certain standard. So yeah, and that gave us, they also had, next to just building SQL, they also had to industrialize things and how to deploy things and stuff. Those were also provisioned via a standard Airflow project with a certain way. They had pre-configured CI/CD that just worked if they pushed to master. So everything was just nice, smooth sailing. Kinda. Like for most cases, it's a nice smooth sailing to deliver a data product. You just had to add your SQL and then you could go quickly to production.
Were there any exceptions to these rules?
Yeah, mainly with ingestion. Ingestion is always hard, right? It's very custom. Every database is different. So the exceptions mainly occurred with ingestion cases. But even for ingestion, and that's the power of, for example, Starburst, since it could connect to different databases via SQL, we could actually use DBT and auto-generate DBT for creating source-aligned data products for a large part of them. Yeah. So even that was standardized quite a bit. But then you had cases like mainframe, which there is no connector for mainframe.
It's always mainframe.
It's always mainframe, yeah.
Or SAP.
Or SAP, yeah, that's another story.
Other podcast.
Yeah, other podcast. And with mainframe, I worked on the beginning of that project, and I remember when we were developing, we got like every other 2 weeks we got a new file format with a different encoding, like file format 1 with an ISO encoding, and then a CP500 encoding, and next time with 2 files instead of 1 file, and it was a mess. So we had this bunch of Python code covering all cases, transforming that files into tables to upload to the platform. But actually, it was a 2-stage pipeline, and that was just stage 2. The first stage was at mainframe. Those guys, very helpful guys, but a bit inconsistent. They would upload it to an SFTP drop server, files, and then we had like a cron job rclone script to copy over the files. Well, actually, it wasn't copying; it was a move, so it needed to be removed from the SFTP, but otherwise the mainframe job would fail. So it wasn't idempotent, which was very annoying because you can't
rerun it easily,
or duplicate the flow when migrating, for example. Maybe we want to duplicate the flow to run in parallel for a while. We couldn't do that because the move was already happened. So you need to work around that. And
it's a bit of an artisanal part of the pipeline, to say it politely.
Indeed. But all in all, I think the number of exceptions we had, mainframe was the biggest one. I think 5% of data products, and so 95% was quite standard.
All right, cool. So then, if we zoom into the migration to the cloud, so you already said like we want to migrate back to the cloud because the infrastructure was not reliable for various reasons, but it was not reliable. There was a business critical data product coming on the horizon. We could not afford the unreliability. At the same time, we added extra security measures, so we are allowed to move back to the cloud. So we're already like the stage is set for a migration back to cloud. The concepts we just talked about, like data products and purpose-based access control, how did it help you move back to the cloud?
Yeah, so the goal of the migration comes a bit back to the trust thing from before, because we had this frail relation with our end users. We had some trust, but it was a bit fickle because sometimes we went out. So the goal of the migration was like, okay, we want to make sure that the impact on the end users is as low as possible. Like they preferably they don't notice anything. So and then it comes to like considering our options, and you have 2 classes. Like either you do the one big bang, like hopefully over the weekend we can just shovel everything over, or you do it more low and slow, data product per data product, a more gradual migration. But since we had this very standardized way across all projects, like 95% of projects were DBT projects, and we knew how they authenticated and how they work for most of them. So we were pretty confident that like a big bang migration would actually be the preferable option, because the advantage of a big bang migration is that the time spent migrating is as low as it can be, and that minimizes your risk, in my opinion, to create data consistencies over time, right? When going with a gradual migration, you need to take into account data product dependencies, like one data source is already maybe migrated, but you need to make sure that also the things that are depend on it and are still on-prem are in sync, and it introduces a lot of complexity and a lot of parts that go wrong. And also you make a lot of assumptions along the way, and assumptions are the places where things go wrong, of course, in a migration.
Absolutely. Then at the same time, big bangs is something as a company we always try to avoid, because big bangs can go wrong, and if they do go wrong, you fail hard, right? It's very much 1 or 0. Like you succeed or you fail. And I agree. A gradual migration introduces a lot of extra complexity, but you get the benefit of iterating over time and improving over time, and trying to reduce the impact to your end users, even though it puts like 10 times the work on you. You reduce the risk. But you guys decided to go for the big bang. How did you guys verify the possibility of even doing that? Because it's a big decision, right?
Yeah. So you say like it put 10 times the effort on us as an engineering team. I think we also used that time we gained to just making sure that the migration, to check our assumptions as good as possible, and take our time, and maybe already fix some things that maybe are not ideal, that just existed over the years, that are a bit of legacy, to take that extra time we have to prepare them in advance of the migration. So everything, the Big Bang migration is as fluently as possible. That's one side note. But what we did as an investigation is we did a lot of things, but the main part is just the lift and shift of things. Like we need to move data from A to B, and can we do that in a consistent way? Like for example, just migrating tables is pretty straightforward. That we could just do. Thanks to Starburst, you could connect to the on-prem environment and just do a Slack star from query. So therefore, you're pretty sure that data was preserved with data types and everything. And we just had to check like how does DBT react, like mainly the special functionality of DBT, like snapshots or incremental models, like what are the edge case scenarios there and how do we handle that? But that, because everything was DBT, we only had to focus on that. Was quite. It was like 2 days of work, and we knew how the migration would behave. Every DBT project would behave.
So the standardization paid off.
Yeah, indeed. Because everything was DBT. That was just our scope. And then we covered 95% of our data products, as I said before. And then the rest of the time we could spend on exceptions like the mainframe to make sure that everything was well prepared there.
Yeah, maybe let's dive into that. So you mentioned mainframe. Can you explain a bit more about what was so difficult about migrating that?
Yeah, as I said before, like it is a 2-stage pipeline. It was also not DBT, but custom Python code. But the first stage was then that rclone script, which moved files from SFTP to our bucket. And so we couldn't run that part in parallel, at least. So we had to build a custom sync between on-prem and the cloud to just facilitate that. And then the Python job could run in parallel, luckily. But also there we had to do quite some refactoring to make that work, and also making the S3 environment compatible with the on-prem environment in terms of settings, like more on a bucket level, like quite technical. Was also a big thing Michiel spent a lot of time on. And then also that the mainframe project itself had a lot of historic tables, kept history without needing it. So it was a bit of a small file problem. So I think it was 50 gigs of data, but it took like 1.5 hours to copy over, which is a long time for only 5% of a total data set, or 1%. My math is not adding up, but for a small part, we took a lot of time, and we only had a limited, in a big bang migration, we want to reduce time as much as possible. So we actually looked in quite a bit to clean that. I spent some time in how can we clean up the history and make the pipeline as a whole more efficient.
So you, because you standardized, you could focus 90% of your energy on 5% of the use cases which needed your attention, right?
Indeed.
And that's something that companies sometimes underestimate, because they believe, and it makes sense, they believe in freedom for the developers. Like, choose the tool that you want to choose, just be productive in your one use case. But then what you end up with, and I've seen it at companies, is that like you have 3 use cases using Kafka, and Kafka Streams, other 4 use cases use Flink, then you have 20 use cases in Spark, and you have some bespoke Python, and there's always an R script lying around. But migrating that, well, not just migrating, it's just maintaining that. You need an engineer who knows all these technologies, like the sum total, right? And here is the opposite approach, where the restrictions give you actually the liberty to move and to change when you needed to change, right?
Yeah, indeed, and in a quite efficient way as well.
Yeah.
Like we took some time, but we also had to prepare some other things more on a compliance side of things.
Yeah.
But in the meantime, we could spend a lot of time like optimizing these edge cases and starting to prepare for that.
All right. So you did your big bang. What was the end result of the migration?
The end result was very positive. Like, we succeeded to migrate in about 14 hours. We had a window of about 16, so well within the window. And we had 0 fallout. Like, I think there was one complaint of an end user who was like the day after the migration, like, hey, guys, my disk space is full. And that's due to the migration. We're like, okay, that's a bit weird. It turns out he ran access locally and downloaded the data from the data platform locally to his disks, and his disk space ran out. Totally unrelated to the migration, but that was our only complaint.
Okay, but it's interesting that he did that, right?
Yeah, indeed. But that's a separate topic, of course. But all in all, it went very smoothly. All the preparation really paid off.
All right. But it's never perfect, right? So what was the main struggle in the migration for you?
Yeah, during the migration day, we had an issue that prod environments had dev environments as a dependency. And that's typically something you don't want. You want prod to only depend on prod, especially upstream things. This was we don't enforce it. Well, I think we're enforcing it now, but back then we didn't enforce it. And we had the assumption, like, okay, to save time, we focus on production first. So we have the most important, we have a limited window. We want to make sure that if anything, if it's slower than expected, that we at least have production. And dev, it's only for the special cases when manual file uploads, like whatever weird stuff you put on the data platform, we don't care, but you probably want that for later. But that's second order. So we had the assumption, like, okay, we migrate prod first and then we do dev. And we actually communicated this to the stakeholders. So like, this is the migration approach. This is how we will solve all the problems. We do prod first to ensure that we are within the time slot, so pipelines are not affected. And they were like, well, that's good, looks good. And the guy eventually responsible for where we had the issues with the prod dev dependency was also in the room. He was like, okay, looks good to me, or he didn't say anything at least.
Ship it.
Yeah, go ahead. So you were like, okay, looks good, sounds good. And then, when we actually migrated, we came up to that dependency, and it was not one data product, it was like a series of interdependent data products who had the recurring issue of like dev prod dependencies. So it was pretty annoying to come up to that. And
but that was basically one data team that built a series of data products, and they kind of, for various reasons, and nobody's they relied on dev.
Yeah, indeed. We didn't have an acceptance environment by choice. So probably they used their dev as more of a validation environment. Okay, yeah, I can understand the reasoning a bit, but our assumption was like, first of all, this is a best practice, so it will be followed. That's the first lesson, right? Like, don't assume your best practices are followed if you don't enforce them. That's a big one, because people will always find a way, will always find the shortest path to a solution. And the second one is also, don't assume when you tell stakeholders something, they will spot your mistakes for you. You really need to be proactive and check your assumptions thoroughly.
And so in the later phase, you plugged the hole, as in you cannot depend on dev anymore, or that's still possible now?
That's a good question. I need to ask the team that, but I know it's on the roadmap to plug the hole.
Of course. And then the impact of the end users. So you had let's say a intense 14 hours of a migration. The users came back. The end users, what changed for them? They had a different connection string. They saw what changed? Nothing.
Like we because the entire platform, as I said before, was a pure copy paste of what was on-prem. So the entire setup was the same. And what we actually did after as a last step of the migration is what we called the DNS swap. So we had the host name of the on-prem environment. We just swapped that to the AWS environment, and therefore, after you needed to give it like 5 minutes or something for DNS caches to clear. And then we even had to add a dummy catalog named AWS, so end users could validate that they could log in. Were logged into the correct thing mainly from third-party client, where we couldn't guarantee like DNS caching to be quick enough. But there was an entire weekend in between. But it can take up to 72 hours. It's a very vague thing. You don't know what happened. So to cover our bases, we did that. So, but zero. Actually zero.
And so when we started the podcast, you mentioned that you were struggling with trust of the stakeholders because the platform went down often. I completely believe you that it improved in the cloud, but did you still have downtime occasionally, or was it completely gone after you migrated to the cloud?
As far as I know, we didn't have any downtime issues anymore. We have some issues with the external key store. That was a lagging thing that became more prevalent because of increased usage with the 200 millisecond latency spikes. But next to that, we don't have any issues anymore. No.
But I wonder, I'm curious, I guess the viewers of the podcast will also be curious, because you still have to do updates to the platform, just like the there's no magic there, right? Even though it's in the cloud, you still need to do updates to this thing. This doesn't magically become high available. Do you know how they avoided the same mistakes as what we did on-prem then?
Well, the advantage is that with AWS, you have these guarantees of your managed infrastructure. While previously on-prem, the infra partner was enabled to give the same guarantee. It was mainly due to if they wanted to update a component, they had to do updates on their side, like on low-level infra side, then that would cause issues. And that's avoided a bit with AWS because they do really, as a business on a global scale, they really go for, 99.99999% uptime. It can happen, but it's way lower.
All right. A purely hypothetical question, but now, if you think about their journey, they went to the cloud, they went back on-prem, they went back to the cloud. With the current relationships with the US deteriorating, and I'm not a political expert, and this is also not a political podcast. But imagine if they come back to us, say, we need to go back on-prem. What would you do differently?
Or
would you say, don't do it? It's impossible.
Maybe look into European vendors then. That's a big thing the last couple of months.
European clouds, you mean?
If possible. Maybe settle there. even though they're less experienced than the big three. On-prem, if we can find a good infra partner, I think we just had a bit bad luck. Like they had quite a good name over the years, but then the last couple of years they started degrading a bit in quality, and that was a bit unfortunate.
To avoid lawsuits, let's not name them.
Yeah, indeed.
But indeed, we were not the only ones experiencing issues with that particular provider, right? So, yeah. Okay. Maybe to wrap up, what is the biggest data lesson you learned from all of this?
I think it was mainly the issues we had during the migration with stakeholders, like check your assumptions and also try to test for your assumptions and document them well. And also don't assume your stakeholders will spot your mistakes for you. Like don't make it an assumption that if something is wrong, they will spot it. No, like you need to put in the effort to get there. Like they won't do it for you.
So in a way, your biggest challenge, your biggest lesson learned is more of a human side of things than a technology side of things.
Technology is easier.
Famous last words.
Yeah. If you spend some time on it, it's always solvable, especially with the team we have. But humans are unpredictable
and more difficult.
Yes. Yes.
Humans don't come with a log and a stack trace and I said something wrong there and that's where the error occurred. It's like, no, you have to...
Or documentation. Well, that's also dependable for technology, of course.
I was about to say, we're not more holier than the Pope here. Documentation is an issue everywhere, I would say.
Yeah.
All right, Niels, with that, I would like to wrap up this podcast. Thank you very much for coming over and talking about the migration.
Yeah, thanks for having me. It's fun.